Well, hello internet. This is the high school scientist, and in this video we are going to learn about the next set of physical quantities. So just for keeping things formal, let's start with area. So when we take length and multiply it with itself, we get area. And when we multiply this area again with length, we get volume. I hope that's clear. Now let's move on to the important stuff, velocity. Now velocity could be easily understood if you try to imagine it this way. Think of a car traveling in a straight line, and the car takes 5 seconds to travel from one place to the other. Now measuring the distance of your journey and dividing it with the time taken to complete your journey will give us the average velocity at which you were traveling. So the expression becomes distance by time. Actually you would be wrong if you say that. When you use the term velocity, you must also specify the direction of the journey, which means using the term distance would be wrong, so you must use the term displacement. As distance is the total path and displacement is the shortest path. This is what displacement is, so specifying the direction with the distance and time is important. And after all this, we get displacement by time, an expression for velocity. But what will be the unit in which you measure velocity? It's pretty simple. Just replace the expression by their base units and we get meter per second. So now let's try to solve this question. A car travels a distance of 300 meters in 6 seconds without changing its direction. What will be the velocity at which the car was traveling? Take the displacement and divide it with the time taken. Here we have no problem in getting the answer as the car is traveling in a particular direction. So the velocity of the car is 50 meters per second. But if there is a change in direction, then how to find the answer? So let's say the car had taken a different path as there was some construction going on. So now the car had traveled 500 meters in 10 seconds instead of 300 meters in 6 seconds. So now if we calculate the speed at which the car was traveling, we still get 50 meters per second. But when we have to find the velocity at which the car was traveling, we should not consider the distance, rather we must consider the displacement. So displacement is the shortest distance from A to B, and when we take this displacement and divide it with the time, we get 30 kilometers per hour. So the velocity of the car while it was traveling was 30 kilometers per hour. So that's it, you have everything you need to measure velocity. But still there is one big unanswered question. What is the use of measuring velocity? Frankly speaking, in our day-to-day lives, we don't have much use for velocity. But in scientific studies like motion of electrons, studies based on light, and every space mission requires measurements based on velocity. So now that we have a good understanding about velocity, we can move on to acceleration. Now put it in simple words, the change in velocity in some time is acceleration. For example, a car can go from 0 km per hour to 100 km per hour in just 5 seconds. So what's happening in this 5 seconds? The velocity of the car is changing rapidly. So this change in velocity over a period of time is what we call acceleration. And the expression becomes velocity by time. So now, what is the acceleration of a moving car? To find how much acceleration has occurred, we can use the same formula. We can subtract the acceleration at the starting point to the acceleration at the end. And if we simplify this formula, we get final velocity minus initial velocity by time. But what if the velocity remains constant and only the direction changes? Because remember, velocity is both speed with direction. For example, a car is traveling at a constant velocity of 50 km per hour and takes a turn with the same velocity and travels in a straight path with the same velocity. So now, even when we have no change in speed, but we have a change in direction, and so we have acceleration. So now that you know what velocity and acceleration is, you are prepared to answer my question. What will be the velocity of this Formula 1 car if it takes 66 seconds to complete one lap? You'll find the answer in the description below. Moving on to the final question. What will be the velocity of light if it takes 8 minutes and 20 seconds to travel from the sun to the earth? You'll find the answer in the description below. So I guess that's it for this video. If you learned something, just spread the word. Let your friends and classmates know about this channel. This is the High School Scientist signing off.